Welcome to this part of the lesson in which we're going to be going through how to use the CAS to solve trigonometric equations. Be careful about whether your CAS needs to be in radian or degree mode when answering a question. So that's a really important thing when you're using your CAS to solve trigonometric equations. Be careful about whether your calculator needs to be in radian or degree mode. Right here are just screenshots of the CAS, and it shows you how to just enter this information in. So we're solving this. As you can see, you've got the domain there as well, and so too over here. Solving domain, I'll be going through some examples that will really spell this out. I also want you to take note of the fact that, as you can see here, this is in degrees, while this one is in radians. So this is just good reference material for you to look back on later, but let's now show you how this works by going through some examples. So this first one right here is asking us to solve this right here, and it's quite clearly in radians because there is no degree symbols. As opposed to over here, you got this degree symbol, so this one obviously your CAS is going to have to be in degree mode. But for this first one, it's in radian mode. Okay, so the first question here has been radian mode. Let's come to our CAS calculator here. And as you can see, it's in degree mode. Well, that's a problem. We're going to have to change it. Go home, go settings, document settings, degree, radian. Hit OK, come back here. And now we're going to enter in our trigonometric equation. We're going to have to solve it, remember? So what we're going to do is we're going to go menu, algebra, solve, and now we have to get our sign. So we go trig, sign, then I'm going to go x, close bracket, is equal to negative 0.3, comma x, close bracket. Now, if I was to hit enter now, I'm going to get this out. And what this basically tells me is that there are an infinite amount of solutions. And we don't want an infinite amount of solutions. Rather, we've been told in the question that there is a restricted domain. So what I'm going to do, if I just go up, and hit enter, it just brings it right down for me, which is very nice. And now I'm going to go control this one. This symbol right here is such that, and now we can type in our domain. So it's going to be 0, control this is less than x, control this is less than 2 pi. Now when I hit enter, I get these out. So 3.44, 5.97. So what I'm going to do now is I'm going to put these in. There we go. Sorry, just fixing things up. So that means my answers are going to be x is equal to 3.45. Let me just round them to 2 decimals, and then 5.98. Now it's important to realize what these are. Like, what have we just found? It's not good enough just to be able to get the answer. I want you to understand what we've done. So if I just draw my unit circle here for a second, I can show you what we've done. Now I've got sine, which means I'll be looking here, and then it's negative 0.3, so it's going to be right here. So that's going to correspond to here and to here. So what we've just found is angles to these points right here. So this one is going to be something negative 0.3, and then over here it will be something negative 0.3 right there. Okay, so what we have found is the angle that will get us these values. So this right here is our smaller one, so it's going to be this one, and then our bigger angle, so all around here, is going to be 5.98 radians, and that's what we have found. Now it's from 0 to 2 pi, and that's why we only have to consider going around the unit circle once. So that's what we found. We found the angles that give us those values out. Let's now come to our next one here. And as you can see, our calculator needs to be in degree mode. So let's bring our calculator back. Okay, so at the moment it's in radians. That's a problem. Menu, settings, document settings, degree to radian. Okay. And I come back here. And now I'm going to type in my question, which is, well, first I have to go menu, algebra, solve, and then I'm going to go trig, sign of, oh, sorry, it's cos, whoopsie daisy, trig cos of x is equal to negative 0.7, comma x, trig, sorry, not trig, that button, 0, this button, that one, x, this button, then 2 pi. The thing that people always forget is this comma x. Don't forget the comma x. Then I hit enter, and it says false. What have I done wrong? what I've done wrong here is that it's in degrees, but I put in 2 pi's. So what on earth was I doing? I just stopped concentrating there for a bit, but let's just use this as a learning experience. Obviously, I had to put in 360 degrees because it's in degrees. Now I hit enter, there's my answer. So let's pretend I did that on purpose. Okay, so now what I'm going to do is just put those answers in. So I come over here. So that means right here, I'm going to get x, let me do this in red, just to be consistent. X is going to be equal to 134.43 degrees. Make sure you put the degree symbol. 225.57 degrees. And again, you should be able to just understand what we have just done. So if I was just to draw a unit circle here, I'm dealing with cos, so I'm looking at my horizontal axis here, and then it's negative 0.7. It's going to be about here, there. So that means this one is going to be here, so that angle, and this one is going to be that one. And that makes sense because this is less than 180 degrees. This is more than 180 degrees. Perfect. So that's what we've done. All right, let's answer these last 2 right here. What you'll notice is that the domains are a little funky, and we also have a coefficient in front of our theta. All right, so let's answer these. Oh, we also have to take note of that they're both in radians. They're both in radians, so that's going to be important. So they're both in radians. So I have to come here, and I immediately have to change this degree to menu. Whoops, I did this one. Settings, document settings, degree, radian. Okay, hit there. And now I'm just going to type in what we have. So menu, algebra, solve, and then it will be trig sine 2x is equal to 0.2 comma x, and now trig that 0, trig that is less than x, control that is less than pi. So just hit that to that. That's going to be my answer there. So sine of 2x is equal to 0.20 to pi. That looks good. Then the next one, so let me do it again. Menu, algebra, solve. Then it was cos, trig cos, and this was 3x is equal to negative 0.6, whoops, comma x, trig that, sorry, not trig, I keep saying trig, and then it's going to be negative 2 pi, control that is less than x, control that is less than 2 that to there. And as you can see, you get multiple answers out to that one. All right, so you can type in all those answers there into these spots right here, so you can write them out rather. What you might notice is that in the question it said theta, but I just put x in there, and that's just because I'm lazy. If you wanted to, you could put theta in. You can do whatever. You would W in. What the pronumeral is doesn't matter as long as you're consistent. Just make sure you read the question carefully and you do what it asks, and make sure you're putting in the domain correctly. Make sure you realize whether it's in degrees or radians. That's important as well. So I'll let you write all those in and just make sure that you're comfortable with doing this. The last thing I'll say is that if you have a new calculator, so the CX2, I think there's an easier way of changing from degree to radian mode. I'm pretty sure you can just click here and it'll give you the option to change. I'm not 100% sure of that, but if you do have a CX2, I'll be interested to chat with you to see if there's a quicker way to change from degree to radian mode. That would be really helpful. And with that being said, I will let you go, and I will see you in the next lesson.